Have you ever faced a frustrating issue while coding, only to find that a simple naming conflict is causing all the trouble? If that's you, then you're in the right place. Today, we're diving into a C++ issue involving std array and naming conflicts. I totally get how annoying it can be when your code compiles perfectly in one version of a compiler but throws errors in another. You're definitely not alone in this struggle. Many developers encounter similar issues when working with different compiler versions. Let's take a closer look at the specific situation. One user recently encountered a regression with GCC7 in their C++ JSON library. They used the name array for both a member variable and a static function. And now they're wondering if this is causing the issue. Sound familiar? Let's dig into this together. So what seems to be the problem? The user's code compiles fine with GCC6 and Clang 5, but GCC7 throws an error about the wrong number of template arguments. This suggests that the compiler is misinterpreting the member variable array as std array. Let's break this down. And stick around. I have some practical solutions to this naming conflict that you won't want to miss. Plus, a bonus tip at the end that could save you from similar headaches in the future. To address the issue with the code, the user should first understand that using the name array for both a member variable and a static function can lead to confusion in the compiler. This is especially true when using the using directive for std array. The user can resolve this by either removing the using std array directive or moving it below the inclusion of myclass.hpp. This will prevent the compiler from misinterpreting the member variable as a template. Alternatively, the user can modify the comparison line in the operator function. By adding parentheses around lhs.array, the compiler will correctly interpret it as a member variable rather than a template. Regarding the user's questions, yes, the code is technically correct, but the naming conflict creates ambiguity. As for the behavior in GCC7, it can be seen as a stricter interpretation of the C++ standard, rather than a bug. Fun fact, did you know that naming conflicts in programming can lead to some of the most bizarre bugs? It's like when you call your dog cat, confusion is bound to happen. Now let's look at the answers provided by other users. The user points out that the behavior observed in the code might not be correct according to the C++ standard. They explain that when using member template specializations, the keyword template is required in certain contexts to avoid confusion with non-template names. They suggest a workaround by using parentheses around the member accesses to clarify the intent. Additionally, they simplify the code by moving the value t-struct outside of the template, which helps avoid conflicts with the std array template brought in by including the array header. They conclude that, while using the same name in different contexts is allowed, it can lead to confusion, especially when the name suggests a different meaning. Here's a pro tip. Always be cautious with naming conventions in your code. Using clear and distinct names can save you from these kinds of headaches in the future. And there you have it. With these solutions, you should be able to resolve the naming conflict in your C++ code. Remember, clear naming is key to avoiding confusion. If you found this video helpful, hit that subscribe button for more coding tips and tricks.